Dear friends, in this video we are going to discuss about another important parameter called the temperature, how the temperature can be measured, how the temperature influences in the functioning of various equipments in engineering and other medical field. There are various tools available for measuring the temperature. It is easy to handle and everyone can measure the temperature of the body, temperature of the surrounding, temperature of the water, whatever can be easily measured, and some complication also there. To measure very high temperature we need some other equipment, non-contact type equipments like a pyrometer. Optical pyrometers are there to measure non temperature of high degrees. So now we will go how we are going to measure the temperature. The commonly known method is thermometer. Everyone knows the thermometer, thermocouple, RTDs, that is a resistance temperature detectors, and bimetallic strips. So before going to these measuring instruments, measuring tools, first let us know what is the temperature. It is nothing but the movement of molecules, that is kinetic energy of molecules, individual molecules that comprise the component of the system. That movement raises the temperature. So we can classify the temperature measuring device into two types, as contact type and non-contact type. Contact type means it will touch the component or object or part where on what we have to measure. That is like thermometer, bimetallic strip, thermocouple, liquid and glass thermometer, resistance temperature detector, and thermistors. Whereas non-contact type is radiation type pyrometer, optical pyrometer, and fiber optic pyrometer. The thermal resistance is indirectly proportional to temperature. If you stop the movement of electrons, that is current will be reduced. That is inversely proportional. The temperature and the resistance are inversely proportional. The advantage of this type of machine is it is very high accuracy. It can be manufactured in very small sizes. It has the ability to withstand mechanical and electrical stresses. Drawbacks are self-heating may occur, highly non-linear behavior over its range of operation. That's why it is preferred, but we have to manufacture very high accurate instruments. Applications we are finding for varying temperatures. It is used in time delay circuits. Thermistors are used for temperature compensation and in other areas. Bimetallic strip for temperature measurement. That is, no element has the same thermal expansion. Each element is having different thermal expansion. No two metals have same thermal expansion. Coefficient of thermal expansion is different for different materials. That is the basic concept. Upon heating, one metal will get expanded, another metal may not get expanded equally. There is a concept behind the working of bimetallic strip. That is, it consists of two strips of different metals which they expand at different rates as they are heated, usually steel and copper, or in some cases steel and brass. Steel and copper are having different coefficient of thermal expansion. These two metals are joined by riveting or brazing or welding. The different expansion force the flash chip to bend one way if heated and in the opposite direction if cooled below its initial temperature. So it looks like this: low expansion coefficient, high expansion thermal coefficient, free end and fixed end. Thermocouple, it is nothing but a temperature sensor. It consists of two wire legs made from different materials, different metals like bimetallic. This also more or less same. The thermocouple produces voltage when the temperature of the one of the contact points differs from the temperature of the another, knowing the concept called Seebeck effect. The Seebeck effect is nothing but a change in temperature creates change in voltage. Voltage is created when the temperature is changed. That is the basic concept that is called the Seebeck effect. That is, temperature changes, voltage changes. Now look at this Seebeck effect or thermocouple. Two different metals are connected. One is at the hot where we have to measure the temperature, another one is room temperature. When the heat is raised, it will raise a voltage that can be calibrated or that can be measured in terms of temperature. That is, we have to fix the values. For 1 volt, this is the temperature, 2 volt, this is the temperature. Likewise, we have to fix and we can convert and we can measure the temperature. Thermocouple has few advantages. That is, it can be measured for wide range. They are self-powered, do not require any auxiliary power source. Quick and good response. The readings are consistent. They are